So if we look at this particular circuit, so again let us mark the different nodes. So if this is A, so I mark this end as also A. This is B, so I'm marking this as B. Now this end we are considering this entire thing as C. So now if we consider this circuit between A and B, so I can redraw it this way, that there is A, there is a point in between C, and then there is a B. So these are the 3 points between which the circuit is running, A, C, and then B. Now from A to C, I have the following resistances. One is 4 ohm. So first one is 4 ohm. The another one between A and C is 12 ohm. Now between C and B, there are two resistances, 6 and 3. So there is 6 ohm and the another one is 3 ohm. So this is can be drawn as an equivalent resistance diagram. So over here I say that Rp1 is equal to R1 R2 upon R1 plus R2, that is 3 ohm, and then we calculate Rp2, R1 R2 upon R1 plus R2, that is 2 ohm. So the effective value of resistance is going to become 5 ohm because both these combination is in series. So for this problem, option D is correct.